Welcome! Today we'll prove an interesting relationship involving derivatives of inverse trigonometric functions. Let's look at our problem. Let's solve this step by step. First, let's recall what we know about derivatives of inverse trigonometric functions. The derivative of sine inverse of x is 1 over square root of 1 minus x squared, and the derivative of cosine inverse of x is negative 1 over square root of 1 minus x squared. Now let's find y1, which is the first derivative of y with respect to x. Using the derivatives we just recalled, we get y1 equals a times 1 over square root of 1 minus x squared plus b times negative 1 over square root of 1 minus x squared. Let's simplify this expression. We can combine these terms over a common denominator to get y1 equals a minus b over square root of 1 minus x squared. This can be rewritten as square root of 1 minus x squared times y1 equals a minus b. Now for the key step. Let's differentiate both sides of this equation with respect to x. On the left side, we'll need to use the product rule. The derivative of square root of 1 minus x squared is negative x over square root of 1 minus x squared. Let's multiply both sides by square root of 1 minus x squared to clear the denominators. This gives us y2 times 1 minus x squared minus x, y1 equals 0, which is exactly what we wanted to prove. To summarize, we started with y equals a sine inverse x plus b cosine inverse x, found its first derivative, simplified it, and then found its second derivative. Through careful algebraic manipulation, we proved the required relationship between y1 and y2.